As you code, as you develop the software, although you planned uh, relatively seamlessly, considering all situations, cases, but still there may be some missing points that you do not deal with properly. It is almost impossible to consider all unforeseen, unprecedented the issues, unforecasted issues, almost impossible, right? So one minor technique that you can cope with that is to use exception handlings. Exception handlings. With the mathematic understanding, we all know uh, the division is impossible if anything is divided by zero, right? Division is actually, if given any number, if you want to divide by 2, then uh, it is nothing but how many 2's in that entire amount. So with that understanding, if something is divided by 0, then your question would be how many zeros? Someone may say 0 zeros. Someone may say 5 zeros. Or someone may say unlimitedly many zeros. There's no definite answer, right? So division is not possible if it is divided by 0. So that type of things needs to be taken care of in your codings, okay? This example is obviously very simple, so we all know. But many other cases may not be, right? Any value that your program, your code expects 5, then you may clearly specify if it is numeric value 5 or simply character 5. That type of things needs to be clearly defined on your codings. If you're thinking of, for example, advanced dictionary, see here, advanced, this is a variables, dot keys, open and close parentheses. Then those who know Python, then this is a dictionary. Dictionary name is advanced. From advanced dictionaries, you want to consider keys only. So if your code says CID in the list of the keys, then definitely this CID should be here, right? If it is not, then this statement gives you an error. So what you need to do is that rather than explicitly, directly consider this conditional statements or branching statements, you may say, hey, let me try. Let me try if this works. So that is a so-called try. Trial is to be expressed in your codings. Actually, that is the starting point of exception handlings. Type checking. Similarly, this, if that is an integer 5 or string 5. Coverage all cases. If that is a list of something, then you may access all of those. And you want to see, hey, I want to see 59th elements in a list. What if there is no elements available in the index 58? Index of 58 points to 59th elements, right? In Python already. So that is typical error. If you have hard-coded list structure, then you may not miss. What if you receive list data types that may come from internet access because you do not know what's happening in the other side over the internet? Your code may work, but not always. How can we cope with that unforeseen situation? That is exception handling. That happens to conditional statements and while any operations continues iteratively. And also there are lots of systematic errors, mismatches, and time delay, for example. those are things that needs to be handled. So input validation is also known as data validations. So we need to test any inputs. If there is anything improper values, then you have to detect and prevent it. Why? The first bullet says all input data is evil. As you develop, you need to think all input data may be evil. So your approach is to do, hey, which one that I need to pick from evil groups? Okay. So more pessimistic approach in coding or validating user data is needed. Otherwise, they may be, if you do too optimistic, then that'll be the attack, and eventually your resources will get damaged. There may be potential malicious code and malicious users possible. If not validated, attacks, the following attacks possible: injection, and memory leakages, compromised systems, and more. So as we develop, we have to take all the situations into consideration. It is too much, right? So the minimum thing that you need to do is you take every cases, as many cases as possible, all the rest exceptions. Handling a user input. Look at this code. We have a while loop, initially true, so this will go true. You take input from user, so enter your age, convert the user input to integer type, and we do continually this. So what is the issue in this case? This will never end, right? Because we initially true, so this goes all the time true. While in this looping, there is no statements turn this true value to false at all. If you see this, another code in blue, this is a little advanced, so that when user enter the value, then we have here try. Let's see try. If it is converted to integer, if we can convert that to integer, then we got the value age, right? We got the value to these variables. Therefore, that is the time that we stop this loop. If there is anything that we cannot apply this integer, then we will have an error, right? Even if that is an error, then while we are trying, if we don't get this ag value in integer, whatever the value, more precisely, if int function cannot be functioning, here we have int function, then that is an error. So we try this. If there is an error, then go to except. That is the exception case. Exception case may arise here. Then another block here, exception block. This is exception block takes the error and handles. So it may be from this value error, we call that error to E and print that error. Okay. If that is not a value error, then you can raise that exception here using raise statement. Okay. Right now we have only two blocks: try and exception. Try and except. If exception is already known, already implemented, already defined by Python, then we simply use it. We simply take that exception according to this exception definitions and print whatever the description in that exception definition, in this case value error. We write that statement that is already defined in this value errors. If it is not the error, if it is not an exception that Python by nature defined, then we have to define it. Okay, that is so-called user-defined exception. That comes next week. But here, we look at exceptions that are already defined. Then we simply use it. Although we don't know the exception description itself, but because it is already defined, we try to print it. If it is not the case, then we have to define the exceptions separately. There's another class definition exceptions. And then we raise that exception upon the case happens. As we raise that exception, we can put there some descriptions. Yeah, that comes next week. Multiple exceptions are possible. We'll have a lab. So, by the way, we may not. Did I post the lab? Google Colab? No, not yet. So I am going to post Google Colab, IPYNB notebook. Today's date. So you may be able to see it. Now I think you can see it. So that is the thing that we are going to work on. Multiple exceptions may occur because there may be multiple, not only one error cases, but more than one error cases expected in a coding list. Then we need to take them, each one of those. So we ask user to enter an integer for this division. First of all, if user enter the 0, which is something divided by 0, then that is an error. Then that error, probably it has its own error, so we'll look at that. If you do not know any specific error, specific exceptions, then you can global level of exception. That is called the exception. A little specific exception, we call that value error, or some division by 0 errors. All kinds of errors are possible. If it's not zero, if it's not divided by 0, then we perform the divisions. If it is try to divide by 0, then entire this is an error. When it comes to this case, then we raise that exception. Raise exception, and then we say division by 0. This is our exception descriptions, our descriptor. And there we say here exception E, and then we can say that this is an error messages that goes with here exception. If we say print E, then this explanation is printed. And then we can do in this exception block any additional print statements possible, like this. If any, you can not only this, but if it is not integer but string, then that'll be the value errors, right? Why that happens? Because we have a function here, int. Input function takes user input, and then we have an int function. So user entered the characters to be converted to integer. User input characters, not all can be converted to integer. Only the character that you pressed, the number characters on your keyboard. If you press number buttons, number keys, then only those keys or combination of those keys can be converted to an integer. If you say other keys like FGH, then FGH cannot be converted to integer. But if you type 456, then that'll be converted to integer 456. Okay. So user enter the value. If it cannot be converted to integer, then we have an error from here, right? Without this try, your program will hold. But because we have a try, then it goes to exceptions. In this case, it is a general exception or value error exceptions. Whatever available, applicable, it goes there, right? These exceptions, anything that error is caught in this block, and there is, say, raise this exception. In this case, this exception block is performed. This is not that case, right? Then it goes there. Somehow that things. Exception may occur in many cases. If it is an array list, if we want to access it in index, there are all kinds of index errors. One typical index error is that if it is a list, then a list has a fixed number of elements. If your code wants to access beyond, out of that index boundaries, then that is index errors, right? That happens. This particular example appears in our lab, Colab. So we will look at that. Tuple. Let's consider two types of tuples. I think we looked at this, right, last week. Tuple number or list number. If that is a tuple number, then if we want to say here, do some modifications, then there is an exceptions. If we have tuples, if we have a list, then yes, we can perform this the modification statements. But if it is applied to a tuple format, then tuple itself does not allow any modifications. Therefore, error takes place. What that means is that your program halts. If you do not want your program to halt, then you have to apply the exception handlings, and then you can explain it why that happens, right? You raised some exceptions. You can say that, hey, tuple does not allow something. If such an exception is not defined by Python itself, then you can define your own exceptions, and when that the exception case takes place, then you can raise that exception with some descriptions. You don't need to. That is an optional. But if you explain that then it can be handled. Whatever the outcome of that exception handling may make much more sense. So anything comes here, try to update. Okay, then depending upon this data, this function may perform successfully or not. To avoid that, then you within that function definition, you can do try and exceptions. Try this conversion. If it doesn't convert, then you can put there type errors. Type of this, maybe tuple. Tuple is an error. List, no problem. You can say that here. That happens in a dictionary as well. So user input data, then we have to sanitize it. As we do sanitize, we need to do some exception handling, exception blocks. Not only the data directly from user, but also data that may be available in a data types that we looked at: list, tuple, and dictionary. Data if comes from outside, from the internet, that also may be in specific data type, or maybe simple data items. Then that is similar to the user input data items that you have to handle the error cases, exception cases. Now we look at the dictionaries. So look at these dictionaries, key and value pairs. The value, here we have the list of values, right? Value list. To the key, we have a value list. So third, okay, key, or this is simply returning the values. If we give key, then it returns the values. Then what happens here? We need to give a key, right? But we do not know the key. Luckily, if we know the key, so that, hey, what is the value for the key B? Then there is a B, so that we can get this value for this specific the key. But there may be keys that is not available. but still wants to get it, then when it comes to this, then we'll have an error, right? So how can we handle this? This is an error, and it says key errors. When you execute this, if your Python complains with a specific exception name, key error, it says key error colon F. So there is a key errors. Then using this, the exception names, then we can rewrite this. Maybe in the, not in the following slide. We will look at this, okay? So this is the concept. Any data comes, or data may be performed within a function that should be handled properly, or that should be sanitized properly. But not all such cases can be planned. If it is so, then that is really ideal, but not always. Therefore, we need to set up, try our regular logic with the exception block, where something additional needs to be handled when exception occurs. So I posted the Colab files here. So what you need to do is to download this, save it in your local drive, and bring that up from your Colab. So colab.research.google.com. You need to upload that. Then you will have this exception handling in Python. There are two types of exceptions, built-in and user-defined. Today we will look at the built-in only. This is a very basic, simple example. If you execute this, then you have an error. Error exception is called the zero division error. So you need to take that here. So you can complete this. How can you complete? You simply do the same logic that you have. That logic should be done in your try block. Try block and your exception block, the division errors, and you can do here, try to see what is the description from this exceptions. So if you call this, wait a minute, dot division by, only simply division by error. That's what it says, unfortunately. But if you want to say here more, then you can see print so this is errors. This is handled, right? So first statement is coming from this between exception definitions, and then second one is my comments, right? What if the exception, yeah, rather than this, what if we do simply, rather than any specific, we do not specific level of exceptions, but a little more general level of exceptions, then we can do exception, right? Then if we print, it says only here, E, that comes from here, E goes into this placeholder. So that comes here, division by 0. So still it takes a proper exceptions. Work similarly? Yes, they work similarly. So we look at the part 1 exception handlers. User input may be incorrect. This is not complete. I'm still working on this. Single exceptions. We have a while loop. This is what we looked at, right? So let's try to do this. Enter user ages. So 88, enter. 69, enter. 45, enter. It never ends, right? So if you want to stop it, stop it. And it says only the interrupted right now. But this is a logic issue. We never, there's no terminal conditions. What that means is that there is no terminal condition is specified. Therefore, it goes forever. In the case, it goes infinitive loop. Infinitive loops may cause your code the exceptions, but not always, right? In what case infinitive loop is okay, or infinitive loop is needed? In what case? Nowadays, in cyber physical world, all physical systems, there's no pure physical systems available. Even gasoline engine automobile is not only the physical mechanical systems. Now, so more and more electronic or computational components added. Therefore, we call all such environment cyber physical infrastructure. In the cyber physical infrastructure, then we need to, your codes, your developments needs to monitor the physical condition changes. When something happens, then your code needs to do some handlings. And then that monitoring system should run, should never end. If that operation needs to go continually, then that is nothing but infinite loop. So more and more, purposely, the infinite loops are designed. But if it is not the case, then we have to take care of that, right? That is here. So try as many as you issue, what kind of exceptions that you have. If you do not take it from, this goes slowly, but if you do this continually, so rather than take this from user, but if you say start number is 1,000, and then you can do start number plus 100, and then rather than saying that, you can do there's a start number times 1.5, and this go forever, right? Infinite loop. So if you do this, I do not want to write statements. Yeah, we cannot do write statements at the end. So here we do simply print with the tab, print with the tab, and ag, and there's no end, so it goes forever. So if we run this, It goes forever, right? At some point, this guy says, "Oh, there's an error," but it's not really errors. It's infinite loop. It doesn't complain. It doesn't catch. There's no terminal statements. When the memory reaches, yeah, still runs. It doesn't catch it by itself, but anyway, if I click this, then that is nothing but the keyboard interruptions. Because of the keyboard interruptions, this guy may stop, right? Keyboard interruptions. No other additionals. So our fixation is we need to change this to the logic change. Logic needs to be changed. In other words, if we do it the proper way, go back to the original stuffs. This is not the case. And then we can say if ag is greater than 120, then we need to stop, right? So more input needs to be false. So we can enter the value 6 years old, 7 years old, 45 years old, 65 years old, 78 years old, 88 years old, 99 years old, 101 years old, 111 old, 112 old, 117 old, 118 old, 119 old, 120 old, 121 old. Stops, right? So secure. There may be multiple exceptions may occur. So we will look at that. This we looked at. We divide still divisions. Given 23 nominator, and we have denominator. So enter an integer, we convert into integer. If it is not converted, then it goes to whatever the value here. So user input value y, if it is not 0, then we need to divide it, right? So we have to look at carefully what we will do here. We simply here the print statements, so that we can do print nominator divided by denominator equals whatever the outcome that is possible for this x, y, two values. We can x divided by y. So the real action takes place here, and then that value goes into this placeholders, right? If denominator is not 0. If it is a denominator 0, therefore raise the two exceptions. It's not really say something, but we can do here if y equals 0, if a denominator is 0, so intention is to divide something by 0, then we print that y, and then we need to raise that once. Otherwise, that is an exception. In that raise it, we can say, what are we going to raise? We can raise any exceptions, or we can raise the exceptions that we looked at earlier. What's that exceptions? yeah, zero division errors. Okay, so we'll get that zero division error exceptions. Here raise zero division error. We rename it, say ZDE, zero division errors. Zero division error. We simply raise it, and then this is if else if, so that all the rest. For example, user wants to enter the number but zero, then we have these exceptions. Other than non-zero number, then we can compute that. If any user given enter is non-numeric, then it goes to these else statements. Therefore, here we can say we can raise simply exception. This doesn't make sense here. Raise, we can specify, for example, try to divide by 0. Let's see why that is. We can do raise, right? That should be within that parenthesis, parenthesis. So we need to put that here. Within that parenthesis. Same thing here, then we need to do unacceptable. Exception error, we can print something, but we can simply print E. Well, that comes here E, so we don't need. You know what? Let's do this simply. This, and we separately the exceptions from this exception handlings. Value error comes from there, and we can do also except zero division as zero division error, and then we can do print zero division error. Okay, so try. If we put 0, then yeah, 0 enters. Try to divide by 0. That's what we have here, right? Try to divide by 0. So that's this exception is taken, and then that 0 is not value error, but that is a general exception. So we have this error, this exception also handled for the case of 0. Multiple exceptions handled. If we do simply 12, then no problem, no exceptions. If you handle, for example, user asks to enter integer, but if I type cyber enter, then user enter cyber. So invalid literal for int with the base 10 cyber. So I believe that comes from here, this value error. And also this value error, that also applied to exception. That is also part of the exception. So 2 exceptions are caught and handled like this. So if we try to show only one exception, then we comment this exception. Still, it works, but only one exception is caught and handled. Cyber, then these exceptions, value errors. So that should be applied to integer, but integer is not possible. So this error takes place. If we put here 0, then only in the case also try to divide by 0. This error is handled. If we don't do anything, this, then as we looked at previously, default, the description is printed, which is divided by, if we do not raise, okay, but we handle the exception, still doesn't do the specific. I think we looked at somewhere. When you do this, division by 0, it comes from this, division by 0. Not in this case. Strange. Where is it? Yeah. Divide by 0. That is the exception. Goes here. And I want to print something available from this exceptions. But it doesn't print. It prints only 0. That 0 comes from here. This is printed, right? Because there is nothing, then we can say pass. So if we do 0, enter, nothing happens. Print this. It's not printed. I do not know why. Should be. Okay, so with that simple understanding, then there is a homework assignments. Out of bound errors. So enter user age. So you need to put the enter user age, then take that user age. If age is in this range, then that is okay. But other than that, out of the bound. Enter your age 101 out of bound. Anything within this, then that is okay. Your age is 35. 55. So do this. Complete this. More examples. So in the index, so random number is generated. So 10 times random number is generated, and that is entered into this list. Initially empty list. Now we construct a list like this. So if we do that, I comment this, then we will do this. This is 10 elements, each from in this range 11 to 100. So we make a list. Okay, and then let's say if we want to print any specific LST number, I want to get 10th element in the list. See what happens. Of course, if I want to get 10th elements, then I need to put here 9, right? Index 9 points to the 10th element. But for some reason, if I say the index 10, which is out of this boundaries, then it says index error, list index out of range. That needs to be handled, right? So in order to handle this, then you need to do try, and then except. There you can use this index error. In this except, index error as IE, and then print IE. You handle this, then it says simply index errors, right? What is this? So for a number of a combined, the list and the print. or this is listed. In this way that we can handle it, right? So similarly, if you want to do for loops here, try to do something from 35 to 72, but without print that. So error here is that whatever the length, but we want to have one more than the length of this list, and I want to print that. Then without try, then we'll have an error. Here an error, list index range, right? So to avoid it, then we need to do try. And then except, simply exception, print E. Then we do not have an error. It says a list index out of range, simply, right? So without try, except, then the way that we looked at previously, we have an error, right? Similarly, yeah, already made that. Yeah. Homework 1.2, 1.3, I want you to do that. Consider dictionary. That goes up, right? This is a new ones. Okay. Okay, now another example. There is an error, right? So if we do this, this function is to take username and account. Username and account. So for example, Adam, there are two types of accounts, checking account and saving accounts. So if I say Adam and checking account, then it returns the balance of their accounts. Okay, so bank accounts, Adam, this is a dictionary. Adam is a key, Adam, Bob, and Chris, 3 keys. For each key, we have a list. First number in the list is a balance of the checking accounts. Second number is saving accounts balance, and so on and so forth. Bob has only one element in a list, then that is nothing but checking accounts balance. So that is the bank accounts like this. So when user gives us a name, then we can access this dictionary by key. So bank accounts in the bracket name. Take the name into this dictionary access form, then we'll get the value. Okay. Value means a list together. Adam has a list, Bob has a list, Chris has a list. But if for each list, we have a checking accounts and saving accounts. If this guy wants checking, then we will get the first element in the list. If this guy wants to get the saving accounts, then we will get the second element in the list and return that. If anyone does not say anything, checking or saving, then both of those. So by can say Chris didn't say anything, then it's okay. We should say something. Should say something. So oops. Typo. Okay. Then 7 and 8, which is that's not either checking or savings. So I think it should be this way. So without saying anything, oh, it two parameters, right? So anything should say then 7 and 8. This type of things can be sanitized here, but I didn't sanitize it. So far so good. But if I do, say, Bob saving, what happens? If I do Bob saving, then list index out of range. So what is Bob? Bob saving. Bob has only checking accounts. There is no saving accounts, right? So that is the reason this happens. And the last ones, if I check it, then David's checking accounts. Of course, there is no David's. It says key error exceptions. The first one is so what is it? This is homework 3, right? So I want you to handle this. How we can avoid this this kind of errors, so that this color, all of this color should work, right? One challenge, even if I have only one parameter, although this guy needs 2 parameters expected, if I call by only one value, of course then there is an error, right? The error, it says balance missing 1 required optional arguments. Account is missing, right? Second parameter is missing. So is there any way that we can avoid this? This is not mandatory, but those who complete whatever that, so without this, all color statements needs to successfully work. And if your code handles that, that'll be fine. Those who complete it, then I want you to consider this, how you can work. You can handle it. Think about that. So you can complete that here. And then there is a user-defined exceptions, which comes later next week. All right. So today you will have 3 homework problems: 1.3, 1.2, and 1.1. Somewhere here. Yeah, 1.1. Yeah, that is your homework assignments. This is it.